Hello everybody, welcome to NEET Physics by our video channel. In today's video, we are going to solve an MCQ in motion of system of particles and rigid bodies. Motion of system of particles and rigid bodies. Okay, what is the question, sir? Let us look into the question. Two discs, this is one disc, this is another disc, of same moment of inertia rotating about their regular axis passing through the center. So this is the cylinder, this is the disc, this is the axis passing through its center. Okay. So and perpendicular to the plane of the disc. So this is the plane of the disc, the axis is perpendicular to it. Yes. With angular velocities omega 1 and omega 2. So this is the final figure. Actually, initially this disc and this disc are revolving at a different place, at different places. So first disc is having the angular velocity omega 1 and the second disc is rotating with the angular velocity omega 2. They are separately, they are rotating. Okay, and then they are brought into contact face to face, coinciding the axis of rotation. This is shown in the figure. They are brought into contact face to face, coinciding the axis of this is the common axis of rotation. Now they are rotating. Now they will rotate with the common angular velocity. Is it not? Okay. Now the expression for loss of energy during this process is how much? You are given four options. 1 by 4 into I into omega 1 minus omega 2, the whole square. Option B, I into omega 1 minus omega 2, the whole square. எல்லாத்துலயுமே I into omega 1 minus omega 2, the whole square. அப்படிங்கிறது இருக்கு. Here it is 1 by 4, this is 1, this is 1 by 8, this is 1 by 2. That is the difference. Okay. So now, by law of conservation of momentum, you know that total angular momentum before the process is L1 and the total angular momentum after the process is L2. This L1 and L2 are equal. This is according to law of conservation of angular momentum. Okay. Now L1 is equal to, that means what? Before the contact, the two discs are rotating separately about an axis which is passing through the center perpendicular to the plane of the disc. So in this case, L1 is equal to L1 for I omega 1, that is angular momentum for the first disc, I into omega 1. For the second it is I into omega 2. So is it not I1, I2? No, because both the discs are having the same moment of inertia that has been given in the question. So moment of inertia of disc 1 is equal to moment of inertia of disc 2 is equal to I. So no I1 and I2, L1 is equal to I omega 1 plus I omega 2. Then what is the angular momentum after they are made into contact? That when the discs are brought into contact, they will rotate together with a common angular velocity. How to find the common angular velocity omega? Already I told you that by law of conservation of angular momentum, L1 is equal to L2. What is L1? I omega 1 plus I omega 2. What is L2? Total angular momentum. So both the discs have the moment of inertia, I1 is equal to. So totally I plus I. Another to say 2I into common angular velocity. So 2 into I. Okay. Then what is omega? So I omega 1 plus I omega 2. L1 is equal to L2. Instead of L1, you put I omega 1 plus I omega 2. Instead of L2, 2 I omega. So then I gets cancelled. Okay. We are having dividing the equation throughout by I, you will get omega 1 plus omega 2 is equal to 2 omega. It means what? Omega is equal to, we can put 2 to the other side, 1 by 2 into omega. When it goes to the other side, it will become 1 by 2. So omega is equal to 1 by 2 into omega 1 plus. Now, what I have to find is the difference in kinetic energy or change in kinetic energy. What is the formula for kinetic energy of rotation? Initial kinetic energy is equal to Ki is equal to half I omega 1 square plus half I omega 2 square. Kinetic energy for the first disk, kinetic energy for the second disk. Okay. Then what is the final kinetic energy? Final moment of inertia. It is 2I. Addition of 2 disks, 2I into half into 2I into omega square. That is omega 1, no omega 2, only the common omega, final angular velocity omega. So 1 by 2 into 2A into omega square. 2 and 2 gets cancelled, you have only I omega square. So in the equation for Kf is equal to I omega square, you can substitute the value of omega. What is the value of omega? Just now we can see that omega is equal to 1 by 2 into omega 1 plus omega 2. Then what is omega square? Omega 1 plus omega 2 the whole square divided by 2 square. What is 2 square? 4. So substituting the value of omega, this equation Kf is equal to I into instead of omega square, omega 1 plus omega 2 the whole square divided by 4. And the I by 4. Now, what is the loss of kinetic energy? Initial kinetic energy Ki minus final kinetic energy Kf. Is it not? Okay. So, loss of Ke is equal to Ki minus K. Yeah. What is Ki? 1 by 2 into I omega 1 square, 1 by 2 into I omega 1 square, plus 1 by 2 into I omega 2 square, 1 by 2 into I omega 2 square, minus Kf. What is minus Kf? I by 4, omega 1 plus omega 2 the whole square, omega 1 plus omega 2 the whole square. So, loss of Ke is equal to 1 by 2 into I omega 1 square plus 1 by 2 into I omega 2 square minus 1 by 4 into, what is this value? This is similar to A plus B the whole square, A square omega 1 square plus B square omega 2 square plus 2AB, 2 into omega 1 into omega 2. Okay, yeah? Yes. Now, so loss of kinetic energy Ke is equal to 1 by 2 I omega 1 square plus 1 by 2 I omega 2 square. You put the minus I by 4 inside the bracket. So minus I by 4 into omega 1 square minus I by 4 into omega 2 square minus I by 4 into 2 omega 1 omega 2. Is it not? Now you have I by 2 into omega 1 square. Here I by 4 into omega 1 square. It means what? Minus I by 4 into omega 1 square. It means what? That is 1 by 4. This is 1 by 2. This is 1 by 4. Kalicha, subtract 1. If you subtract it, you will get 1 by 4. 1 by 2 minus 1 by 4 is equal to 1 by 4. So 1 by 4 into I omega 1 square. Similarly for omega 2 also, 1 by 4 into I omega 2 square minus the last term 2 into I into omega 1 omega 2. So here you have I by 4. Here also you have I by 4. Here also you have I by 4. Take this as a common factor. So loss of Ke is equal to I by 4 into omega 1 square, omega 1 square, omega 2 square, omega 2 square, minus 2 omega 1, omega 2 omega. So option A is the right answer. Okay. So loss of Ke is equal to I by 4 into omega 1 square plus omega 2 square minus 2 omega 1 omega 2 is the first option, and it is the right option. It is the right answer. Okay. That's it. So far we have seen about 7 questions in this chapter. In our next video, you will see a question from some other chapter. If necessary, if required, you can see more problems in this chapter also at a later stage. Okay, till then, thank you one and all.